Hi everyone. In this video, I'm going to go over some problems related to energy and momentum conservation and talk about when to use each of these ideas. So we're going to look at questions 71 through 75 on the physics regents from 2022. And you can see that it's a lot of information, so we'll break it down into a few parts. A spring with a spring constant of 2,600 newtons per meter is compressed 0.1 meters from its unstretched position. I boxed the words spring constant and compressed to help me figure out what these numbers mean, and this information is represented in the image here. The spring is released, propelling a 3 kilogram block along a horizontal frictionless surface. So the spring is released, and now this block starts to move. I put a box around horizontal because it kind of tells me that there's no change in height, and it can rule out a gravitational potential energy. I boxed frictionless because I know that no energy is being lost from the spring being compressed to the block starting to move. This block then collides with a stationary 1 kilogram block. The blocks remain joined and move together as shown in the diagram below. I put a box around collides because every time there's a collision problem, I know I'm using P before equals P after. Stationary is going to be important for that section of the problem, and moving together is also going to be important because that's the equation that I have to expand on my own, and these are going to help me figure out how exactly I should do that. So let's start with question 71. Determine the total amount of elastic potential energy stored in the spring when the spring is compressed 0.1 meters. Since they asked me for elastic potential energy, I know that PES is my unknown, and there's only one formula with PES, so I just went right to PES equals 1/2 kx squared. We can take a look at this information that we annotated. I need the 2,600 newtons per meter, that's going to be my spring constant, and I need 0.1 meters, that's going to be the distance that the spring was compressed. So I have k equals 2,600 n/m, and x equals 0.1 meters. Now I can just plug those numbers into my formula. I strongly recommend plugging this entire thing into your calculator at once. I think that's the best way to avoid any calculator errors, and you should get 13 joules as your answer for 71. Questions 72 and 73 say, assuming all of the spring's energy is transferred to the 3 kilogram block, calculate the speed v1 of the 3 kilogram block immediately after it is propelled by the spring. And you're supposed to show your work for this question. So I put a box around this whole phrase, spring's energy is transferred. If we look at this diagram, basically when the spring's energy is being transferred, that means we started with a certain amount of potential energy. Specifically, we started with 13 joules. All of that energy is being transferred to the block in the form of kinetic energy. And I know it's kinetic energy because kinetic is related to motion, and they're talking about speed of the block. So I put a box around this phrase because that kind of gives me information about how much kinetic energy I have. So I have 13 joules of kinetic energy. And since I know the kinetic energy and I know I'm looking for speed, this is definitely the formula I'm going to be using. They told me the mass is 3 kilograms. There are 2 blocks, but they've specifically asked me to talk about the 3 kilogram block, so that's what I'm writing down here. And I'm looking for the speed. I'm going to write v1, and so I'm going to make my formula say 1/2 m v1 squared, just because later we're going to have a different velocity, so I want to make sure I know which one I'm talking about. When I plug in my numbers here, I have 13 equals 1/2 times 3 times v1 squared. I'm going to simplify that by just doing 1/2 times 3. That gives me 13 equals 1.5 times v1 squared. These are multiplied together, so I want to undo that by dividing. I'll divide both sides by 1.5. That gives me 8.7 equals v1 squared. And of course, I don't actually want v1 squared. I just want v1 by itself, which means I need to undo this squared. So if I take the square root of both sides of my equation, I get my answer. v1 is equal to 2.94 meters per second. The last part, 74 through 75, says calculate the speed v2 of the two blocks after the collision. And again, we're showing all of our work for this. I put a box around collision because that tells me what formula to use. I'm going to use P before equals P after. I'm going to list out some of my variables first, though. So M1 is 3 kilograms, and M2 is 1 kilogram. And I'm just getting that right from the diagram. V1 is 2.94 meters per second, and I got that from my answer to the previous question. So all three of these questions are related, so I'm taking information from one and bringing it over to the next question. They told me right here I'm calculating the speed v2, so I know that v2 is my question mark. And like I said, the word collision should automatically show me I'm using P before equals P after. The good news is it doesn't have to be super complicated for this particular problem. P before means the momentum before the collision. And even though we do have two blocks, only one of them is moving. So when I make my formula for P before, or when I expand that section of the formula, I'm just going to ignore this block. I'm only going to focus on this one. So I really just have to do M1 V1. Because momentum is mass times velocity, I just care about the mass of the first block times the velocity of the first block. The second block doesn't mean anything to me because it's not moving. I'm going to ignore it. For P after, we see that the two blocks are stuck together and they both travel with that same velocity v2. So I write m1 plus m2, and that's just kind of, I'm pretending it's basically just one object now. One new object of these two blocks smushed together, and then that's their mass times however fast they're going, which is their velocity. When I plug in my numbers, 3 times 2.94 equals 4 times v2. I didn't bother writing out 3 plus 1. I know that's equal to 4, so I just went right ahead and put in 4 times v2. When I multiply this in my calculator, I got 8.82 equals 4 v2. These are being multiplied, so I need to undo that by dividing both sides by 4, and I get my answer. v2 equals 2.2 meters per second.